Good morning, guys. How are you guys doing? That was Bach's Well Tempered Clavier. That was Prelude number 8. What a wonderful song. And the best of them all is the next one, Fugue number 8. So today I'm going to do some Golang, kind of a basic tutorial. So what am I going to do? Much depends on what is this. Okay, this is my Emacs channel. People post stuff. Okay, close that. So I'm going to talk about Golang and where am I where I am going depends on what you tell me to. So you tell me what I want to do, what questions or type comments or opinions, and I'll go into that direction. Either like go into detail about Golang or something else. So keep the comments coming here. So hi Rex, where are you located, Rex? 5 people. Hi guys, say hi. So I'm going to do Golang, and I was waiting for people to come in, and I thought I just listened to Bach. So do you guys hear echoes? Let me know. Do you guys hear echoes? Like yesterday I had echoes, but I think it's set up correctly today. Echoes, anyone? So 5 people watching. So let's see Golang. So this is my Golang tutorial. Golang is the most simple and fairly very elegant language, and also practical, and also widely used in industry, like everywhere. So that's why Golang is a great language, and it's truly simple to learn. You can learn it in 2 days. You learn actually the entire language in 2 days. I talked about that. I talked about this a few times in the past videos. But hey guys, say hi here. Say hi here. Are you guys here? Cause let me know. Cause I don't know where I'm going. So print slice. Let's see. Let's go to slice. I'm doing some corrections. Okay, I'll be right here. So you see, this is a tutorial on Go slice data type, and I'm going to make some little like editing improvements to my Go tutorial. You see this part? Let's search for that. Human. So it's right here, and what I want to do is, you will see, copy that. I'm gonna start in just a minute, don't worry about that. So for example, and let's go here. For example, yay, now look the change. Now look over here, refresh. You see, that's what I want. Well, you need refresh. So print f this blah blah blah, print slice in human readable form, for example this, yeah, that's what I want to do. But anyway, let's start. Okay, so nobody is saying anything, nobody is saying hi. Okay, I'm going to, well, I guess, okay, so I'm going to start. Okay, let's see what we want to do. We're gonna talk about Golang. I'm going to give a basic tutorial, and I'm going to write a prime sieve. Like right now. I mean, in real time. So let's see how how good let's see if I can do that. But okay, so anyway, so if you just go to Golang, sorry, Golang. So if you guys are here new, type the question box. Oh, am I actually sometimes like people, like last time I was talking and the audio is not on. So you guys are here, right? Like say hi in the box to let me know. So I wrote a Golang tutorial here. You can just search my name, Xa Golang tutorial. And why Golang? Because Golang is one of the most simple language. I mean, literally, you can learn the entire thing in a few hours. I mean, really, every book says like you can learn. Hi Rex. So Rex, where are you located? So Golang is the simplest, language. It's great, and also it's very small. I mean, it's like C. Okay, it's very small and it's very fast. The speed of Golang is like C. Okay, and Golang is a static language, and you can compile it like C, C++, Java. You compile the code into a binary, then the binary becomes a program, and you can send the binary to your friends. They don't have to install Golang. They can just run it. You create binary program, but you can also run it like Python, Ruby, or Node.js. You just type something and run it. For example, let me show you. Let's start to show you. Okay, so let's go to my Golang tutorial, and you can see here's my local copy. And let's see, compile, run. Let's go to the first page. Compile and run. So you can see that's the code. And let's go. If I go to here, you see that's I'm in this section, and I press the button, and the code is right here, magnify, and I run it. You see, it says I love cats. Me too. I don't have to compile it. It just runs just like a Ruby. Just like Ruby or Python. For example, let's do Python. Set this to Python mod. Actually, set it to Python mod, and save this file as xxpy3. Okay. Then let's say print Python 3. I love cats. Okay, that's it. You run it, you have it here. So that's Python deleted. So by the way, the program I used to run my Go command, if you are an Emacs user, is this command, xa run current file. You can install it. I mean, you can grab the code. So let's see. So this is the xa run current file, and the URL is actually here. So it's not, it's just like, well, okay, 50 lines of code. You can grab it, and in any buffer, you can just, for example, this is Golang. You can just run it, and you'll output the result. It can be Python, it can be Ruby or JavaScript running Node, and so on, or Camel, and so on. So that's a simple Golang Golang script. So you can compare it, or you don't have to. You can just run it. And most importantly, why Golang? Because many languages, they are good, but they are only academic, meaning that nobody uses it except in academia. Just a tiny fraction of the people, like Scheme, Lisp, or even Common Lisp. But Golang is like industrial language. It's like the top 5 most popular language. Yeah, so it's fantastic. You don't get these properties easily. Simple, elegant, fast like C, and compile or as a or scripting language, and widely used in industry. Meaning that if you are good at Go, you can easily find a job. You get $10,000 a month, or more actually, in over here. So hi Rex, I hope I'm not sidetracking. No, not at all. But how were you able to change the top bar color of your Emacs? Okay, that is actually a bug of Emacs 26. You see this top bar? That's actually a bug. When this happens at first, I thought it's kind of cute, but actually you don't want it. You see what happened is that if I go to my .emacs.d and I go to the directory, you can see there's a desktop file. Now the desktop file is where Emacs sets all the open file, the files you have opened. They are all recorded here because I have the desktop mod on. Now, if you don't know what that is, just search for Xari Emacs desktop. You'll find the tutorial. But anyway, so this file is it records your Windows position, records the files you have opened, records and some other things. So when you quit Emacs and you start Emacs again, it will open all your reopened file. But however, there's a bug because the window position is recorded here. So if I delete that, okay, delete that, close it, and quit Emacs. Do I want to save desktop? No. Okay, let's restart Emacs. Okay, so you see that bar is back. This is normal. But however, if I quit now and if I restart again, then the bar will disappear. It's a bug. So xar start command log mod. So on the left window, you can see all the commands I call. So yeah, Golang is a great language. Let's go back to, let's see the chat. Hi Green Deg. Hi Green Deg. Is that from Edie's config? Yeah. So I hope that answered the question, Rex. Yeah, it's just a bug. I was I don't know how to it's not something that's easily one can easily identify. And actually, well, anyway, that's just a Emacs problem. So Green Deck says, what is the best way to fix one letter misspelling in Emacs? One letter, I guess you just have to like delete that letter and retype it. Is there an efficient way? I don't think so. For example, let's see, I have ch hate here. I want to change the h to e. I just go there. I don't think there is a better way. Or you can use spell. Actually, spelling doesn't always work. Okay. Yes. Yeah, the spelling integration with Emacs is pretty bad because in every dictionary, like in browsers or everywhere in word processors, you can spell check the entire file and it's very fast, and you can correct and it'll give you the correct suggestions. But in Emacs, usually even very simple spelling error, you don't get the correct word. Yeah, so that's an issue. So I guess so are you guys interested in Golang at all? Because I'm gonna talk about Golang. 5 people watching. So I guess I'll continue with Golang then. Yeah, I'm just doing a basic intro. So Golang has these qualities, fast, and so on. So that's really good. I really like it. It's kind of my favorite language now. And okay, when you start Golang, you have to, of course, you go to the Golang website. Do you guys, okay, any of you, what programming languages are you guys typing? Oh, emoji. I don't want an emoji. So what programming languages are you guys, oops. What's going on? 20 minutes. Okay, well, yeah, so okay, so Golang is great. You go to the Golang homepage to download it. Go to Golang programming language. You download it, on different operating systems. You have different ways to download it. On the Mac, you can just use, Brew. Um, okay, where is their download? They don't even script blocked, script allowed. Download Go. Yeah, you just download Go. Once you download Go, you can see. You just type this. Okay, let me start to give you a very basic tutorial. Big button. What do you mean big button? So yeah, let me give you a quick Golang tutorial. Every file in Golang, you must have a package. So every file belongs to a package. If you are just starting out, you are not writing a new package. You just want to use Golang for writing some scripts. Then you just say package main. Okay, and every package must contain a function named main, like this, and that's a function that will be called. So, but essentially, basically, when you start to learn Go, you just put this whole thing, in every file. So that's that. And okay, let's get rid of that. So Golang that, and the Golang file source must be UTF-8. Okay, so you can mostly for Lisp and Emacs. Okay, maybe I'll put some, focus on that. Golang is great from what I've heard. I think ngrok is written in Go. Oh, I didn't know what is ngrok. Let's see. Ngrok. Ngrok. So Green Deck says, I'm not really a programmer, but right now I mainly use Ogmod for taking notes. Okay, that's Ogmod is great for that. So ngrok is a secure introspectable tunnel to localhost. Secure introspectable tunnel to localhost. Oh, there's a tutorial how to use ngrok. So what does that do? A secure introspectable tunnel to localhost. Why you need a tunnel to localhost? Okay, so maybe it looks like not many people are interested in Go at the moment. So maybe I'll talk something else then. Okay, maybe we talk about something else. Let's change the topic. So yeah. So today should it be like technical topic or non-technical? Like I can we can do Emacs demo. Or maybe it's not a good idea to change topic because because I told people that I'm going to do Go. So we got 5 people watching. If you if you have questions, opinion, just say something. Say hi. Type. Say hi. So I know what you like to do. So I'm kind of now. Okay. So So Green Deck says, I hope not too distracting. No, from main topic, but why in Softfly keys D key deleting a character doesn't delete opening? It does. Oh, okay, let me explain that. Okay, I think let's scratch the Golang then, because that's kind of only for some people are interested in that. So let's talk about Emacs. Emacs, the great Emacs. So okay, Softlight Keys is a package that has efficient key binding, and the question is this command. Okay, XOR delete backward char to bracket text. Okay, which normally does this. For example, okay, I press that. You see, it just delete backward one char. But if I have, oops, A, B, C. Okay, now something. Okay, now I call the command. It just delete backward, like delete, 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 delete. Now watch. It deletes the whole parenthesis. Now undo. Now if I move the cursor here, it'll delete, 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 delete. You see, whenever it sees a parenthesis, it'll delete the whole thing. This applies to any bracket. Like whenever it see a bracket, it'll delete a pair. Now, however, here's the problem. However, if you have, if your bracket is not matched, it'll tell you an error. For example, let's try it. Delete, delete, delete. It says scan error unbalanced. That's actually kind of intentional. So to cut to the chase, if you want to delete a bracket like that, not matched, you call this command instead, which is the key number 5. You call delete char. It's bound to the key 5. So for example, my cursor is here. For example, let's see. Delete, delete. You see? Over here, delete. You see? So does that answer the question? So that's why, because I wanted to always be paired, and also it's a good tip that for parentheses or brackets, always type them in pairs, like always, and when you delete them, it just delete, always go by pairs. Yeah. Thank you. Hey George. It's like, George, where you from? Where you from? China? So hey Nicholas. Hey Nicholas. Nicholas, were you from Hong Kong? Was that you? So okay, so that's Softlight Keys, and George is from Australia. Oh my God, are you like Chinese? And you speak Chinese, of course. Wait, are you a Chinese? I know. Like, are you what's the name? Reg, something. Nicholas is from Hong Kong. Uh, okay, cool. So learning Chinese, cool. What about Nicholas? Are you Chinese? So okay, today maybe we just random chat then. So let me type Chinese. Let's see if I can. Ni hao. Ni hao. Wo太太是台湾人，是台湾人。Your wife is from Taiwan. Cool. Okay, Nicholas is Chinese. Okay. So what are we gonna talk about? We kind of 讲台语。So I speak some well, I don't I can understand Taiwanese and Cantonese, but I cannot really speak them. Uh, okay, so what is today's topic then? Guys, let's go. Let's pick a topic. Like, is it gonna be technical? So I have on the YouTube you can see there's a link. You can go there and find a topic, and we're gonna talk about that. So are you guys? Do you guys program, George and Nicholas? Yeah. So we kind of don't have a topic now because we need to we need to get on a topic. We need to get on topic because people is gonna watch after the live, the chat. Uh, so all the other people watching, say something. So not so this NGWOK, I'm not sure what it is. Public URLs for exposing your local web server. Oh, that's interesting. Okay, so your local web server but public URL. Okay, anyway, let's golang tutorial close Bach. Talk about Go. Okay. Learning Golang too. Okay, let's do Golang then. Okay, so I was saying, Golang. Let's go back to the so I was saying Golang's got these qualities, very fast, as fast as C, and extremely popular, widely used in industry, the top 5 languages in the industry, with C, Java, and so on, and Python. And it's very fast, and it's very small, minimum, so you can learn the whole language in just a few hours, like spend the whole day. So and I have a tutorial. So if you just search for Sali Golang, this is my Golang tutorial on my local. So if you are learning Golang, give it a shot. Try my tutorial. So I was talking about, so Golang is great to learn. Then it's very simple. Then you download the Golang the binary file. You download it, and you can just start to run this. Just Golang. Yeah, okay, I know what to do now. So for example, this is the code. You just run it, and you get the result. You don't have to compile it. But if you want to compile, you can. Normally you just type go run test. Your file name. But if you want to actually compile it to a binary, then you type go build test.go. Let's try it. So for example, so here's my Golang file, and the file name is okay, all those, let's delete that. So this is the file name. Let's rename it because it's too long. So let's just say xxgo. Okay, so this is my file name, you can see, and this is the file content. Now if I just want to run this file, I can just type first of all which go. Okay, use the local bin go. That's good. Go test.go. Wait, run. Okay, I have to type run. Oh, no such file. That's right, my file name is wrong. xx.go. That's the correct file name. Okay. Now this is the output, so that's good. Now if I want to compile it, let's see. Let's do go build xx.go. Done. Now if I update the diode, you can see it creates this file xx. Now this file is like 2 megabytes. Now this xx, so I can run it. Xx, you see it runs. Now I can send this xx file, this binary blob to you, and it'll run on your computer. So you can send it to your friends who is using Linux or using Windows. They don't have to have Go installed, because it's compiled binary. So this is a great thing. This is different from Python or Ruby or JavaScript, for example, because if you have a Python program, you cannot send it to your friends. They have to install Python. So this is great thing about another great thing about Golang. So if you look at the file, you see it's all binary file, and the compile time is extremely fast. So anyway, so let's delete that. We don't need it anymore. So that's the very first thing you do with Golang. You go to the Golang website, you download the compiler, the program, then you can start to just like what we did, create this file and start to write programs. So that's about compile and run. And encoding source code is so any Go file must be encoded in UTF-8. Okay, and package. Okay, let's check a little bit for the comments. Web dev at the moment. Oh, okay. So web dev. So George is doing web dev in Australia. Which city in Australia? Can I like I have some, I have some acquaintance, some friends in Australia. So learning Golang. So talk about Go. Okay, let's stick with Go. Yeah, okay. So I want to know your thoughts on typed versus untyped. Okay, that's an interesting question because basically I came from a math background. So in my first 10 years of programming, which is with Western Australia. Okay, so my first 10 years of programming, which is 1990s, okay, starting in 1991. And the language is mostly Mathematica, Wufan language, or Perl. And my opinion about the typed versus untyped was, actually back then I don't know much about computer science. Like I have zero, literally zero idea of anything about computer science. Like I don't know what's a compiler. Like I have no idea about its even a technical definition or whatever. I don't know what is the operating system. Well, I know you have Mac, Windows as operating system, but I have no idea like what is supposed to like do. So in fact back then, so basically most of the 1990s until 1997 or 1998, I started to get into Unix and Perl, Solaris, it's back then. And that's when I started to pick up, learning programming stuff, industrial programming stuff, like compiler. You start to learn these jargons. You have compilers, you have interpreters, you have data types, so-called data types. You have array, you have int, you have float. These are byproduct of computer engineering. So anyway, the first time you are exposed to it, it's kind of strange, especially if you are from a math background. What the fuck is an int? Then you have float, then you have double. That's a complete idiotic concept. So anyway, so up to most of the 1990s, I have no background in industrial programming. Like I don't know anything. The only thing I know is Mathematica. I was fairly the expert at Mathematica because I read the manual 3 times. That's 1,000 pages. Mathematica is a math-oriented language. In fact, it's the most advanced language to date. Okay, it's far more advanced than, let's say, Haskell or anything. Haskell, F sharp, or Camel, or whatever have you, Elm or Pure, whatever. It's not just like better, more advanced, but it's like one magnitude more advanced than all these Haskell or whatever languages. Okay, that's Mathematica. It's still true to this day. So, but it's not a industrial language. I talked about this before a few times. There's a industrial and there's scientific languages, scientific or math-oriented languages, including Mathematica, Julia. Okay, Julia is a modern example. So Mathematica, Julia, APL, MATLAB, R. These are examples of math or scientific programming languages, which are entirely different from the industrial languages. So anyway, so back in 1990s, I don't know anything about. I don't know what does a protocol mean. What the fuck is a protocol? I have no idea about internet. You have internet protocols, you have HTTP protocols, you have TCP/IP, lower level. Like, so back then I remember when reading about, let's say in Time magazine, people start to talk about cyber, you know cyber, when the internet just began, or cyberspace. Yeah, the internet was known as cyberspace. And so people, and hackers, though, yeah, the kind of the early sci-fi, the what's his guy, the guy who wrote the fiction. You remember the early cyberspace? Let's see, CYB space. So, like in the early days, 1990s, the internet is called cyberspace, and it's kind of associated with a sci-fi. Um, Cybernetic and stuff, but Gibson, yeah, that's right, Gibson. So he wrote the book. I forgot the name. What's the book he wrote? He wrote a few very popular books, but I never read it actually. But anyway, so I was saying, okay, so back then I don't know anything about. Like, I remember reading Time magazine. Time magazine was talking about cyberspace, and they also, I don't remember what year, but they mentioned, how hackers or companies, they create crawler, like web crawlers, okay, and this crawler can go to site and do stuff, and back then I remember, to me, I was, what is crawler? This is amazing. How is it possible? So I mean, how so you have this, like, thing that can go into the cyberspace and can hop around. How is that possible? How is it done? Of course, I know today, like, web crawler, you just write a program that just visit websites. Python web crawler. So I have a web crawler here, like, in 20 lines. So I learned. I mean, of course, I'm now old. I'm getting old. I'm 50 years old now. But back in 1991, I was like 21 or something. Um, so I didn't, so when they talk about crawler, I was like totally amazed and captured, fascinated. How can what does it mean? So of course today, of course, I know a lot. So today a web crawler is, a computer program. You it looks just like this. You visit website via TCP/IP stack, the HTTP protocol, and so on. Anyway, so back then in 1990s, so what do I know? I know math. Okay, I'm from a math background, so I was back then very much into math. So I know about algorithms, but from a math point of view, or like all math algorithms, and but I don't know. So the only language I actually know, and in fact know very well, that's Mathematica, which is very advanced language. You don't have, like, in those scientific programming languages, you don't have references, you don't have float. What the fuck, fuck yourself, float. Int, you don't have that. Int, you don't have pointers, you don't have these unnecessary, like, what I would call byproduct of computer engineering. Okay, that's you have that because out of practicality, you hack and you created those, like int, float, double, and references, those things. But anyway, so most people, vast majority of people, they don't have any experience with math oriented programming languages or scientific programming. So most people, when we talk about programming languages, they are mostly industrial programmers. So what they know is about, like, C, C++, Java, Python, Ruby, Perl, JavaScript, and their concept about programming language design or computer science is like they many of them go to colleges, and what they teach, well, the college teach the basics of data structure, uh, the basics of algorithms, the basics of operating systems, the basics of internet protocols or communication protocols, which TCP/IP is just one of them, the most popular and practical one. And so anyway, I'm getting a little bit off topic. So what I'm saying is that uh, okay, so back to computer, be aware that there is actually a good distinction between computer science and computer engineering. Okay, don't I'm not sure about that, George, because Google is gonna ban me if they see that. Yeah. So computer science and beware of there's a huge distinction between computer science and computer engineering. Now, a typical programmer, like all of us, let's say, or whoever works at Google, most of them, okay, or Facebook or Microsoft, most programmers, they what they know is like what they know like is like limited to computer engineering, what I call computer engineering. Okay. Now, however, that's different from computer science. Now, when I say computer science, it's more like theoretical computer science. Now, what is this theoretical computer science? Basically, 99% of programmers in practice, they don't know nothing about. Okay, in theoretical computer science, so in this field, you have data structure, that's part of it. Okay, and algorithm, that's part of it. Okay, these two subjects actually a lot industrial programmers know and are aware of, okay, but not some others, many complexities and many other things. So anyway, I'm getting far from the original question. So what I'm saying is that back in the 1990s, I actually don't know anything about computer science, not the practical ones like what the industrial programmers know, nor the theoretical ones. I just know some math, okay, and I know a lot about Mathematica. But starting in 1998, I started to learn Perl, and I started to learn Unix. I read books. Back then there's not much online. You you go buy books. That's how you learn things. O'Reilly books and other publisher. So I read lots of Unix books, and I joined the startup. Then I started to program. Start my programming career. Well, I was working for Wufan Research in 1995 for half a year. But anyway, so when back then when I first encountered the concept of types in programming languages, I think it's the most idiotic fuck possible. Okay, because the type doesn't matter what is strongly typed or whatever. The very concept of a type, such as int, float, reference type, or double, long, or string. The very concept of type is a byproduct of computer engineering. Why? Why do I think that? Because you see, they don't exist in mathematics. Okay, like in mathematics, you could say you have types. You have real number, you have complex number, you have integers. These are types. Okay, they are you can call them types, different types of numbers. But okay. So anyway, let me see, how do I say, okay, yeah, so since we are talking about types versus untyped languages, uh, first of all, let me just say, so okay, that was my impression. Okay, um, real number doesn't actually exist. Okay, so anyways, so this is in the 1990s. I don't know anything about computer science or industrial programming. That was my impression, because I was very big on math, and Mathematica, I was an expert in Mathematica, the language, which is even to these days far more advanced than all the other languages, even Haskell. Okay, so I'm kind of a weird, back in I kind of a weird person. It's pretty uncommon to have a guy like that who doesn't know anything about computer science, but read the Mathematica book like 1,000 pages 3 times, and know it so well. So anyway, so my impression back then is, type is just stupid. You should never, like never, programming language should never ever have types, except the only exception is that when it is math types, mathematical, like real number, rational number, that's a type. Integers, okay, complex number, then you talk about abstract algebra, rings, field theory, that's my concept, what it should be. But that's back then, I was, literally ignorant about, computer science and lots of things. Okay, so but then, even up to, let's say, up to 2010, so I to today, I have learned quite a lot of languages, Perl, Python, Ruby, JavaScript. I have 20 years of experience coding of many things, and but mostly, okay, I usually don't like any of the typed language, okay, such as C, Java. I know Java, okay. I don't know C, but I know Java. Typed language. Okay, the only two languages I know that are kind of like strongly typed is Java and Golang. Okay, I know only a little bit about OCaml. OCaml is also very strongly typed. OCaml is like Haskell, okay, except it's not as pure as Haskell. Haskell do not allow mutations at all, but OCaml allows that. That's a major difference. But otherwise, OCaml is, you can think of it as a more practical Haskell. F sharp is a variation of OCaml. F sharp is Microsoft's implementation of OCaml. You could say that. I mean, they changed it a little bit. So OCaml is very strongly typed, statically typed. Okay, so the only language I could say I actually know that is typed is Java and Golang. Okay, and okay, so in general, I don't like typed languages because I still have the concept with me that when you have types like Golang, for example, Golang has types. Let's look at Golang. It's like like. Okay, so let me mention another thing. In many of these languages, especially, okay, let's go to Java. Okay, let's go to Java. Okay. Let's say array. Let's just say string, something simple. For example, here's a Java code. Okay, when you so S1 is a variable, you have to declare a type. So, to me, my thinking is that how idiotic must it be? I mean, okay, when you want to add two numbers, or if you want x equal, x and y are variables, for example. I mean, think about math. X is a variable, y is a variable. You want to add them. You just add them. I mean, like in math, do you ever see people say, okay, x is a number, you have to declare it to be a number first, then y is a number first, then you add them. That's silly. In the same way I look at this, it's extremely silly, especially Java. You see, you have to like declare a string. First of all, the very act you have to declare a type is stupid. Secondly, suppose you have to declare, but look at this, something equals to an actual string, so apparently computer can figure it out. Why I mean, I hate anything that when computer can easily, the machine can easily figure out, but the language, does not automate that. So, apparently if you look at this, obviously, the machine, the compiler should be able to figure out, because I'm saying, here's a string, so why do I have to, type string there? So it's stupid in that way as well. So two things: one, declaration of type is just stupid by itself. Two, okay, even let's say you want your language to declare types, but it should be automated. In this case like this, it's just stupid to still need to type the type, type the type, type the type, and but there's more things stupid about Java, but it's unrelated now, because Java now you have string buffer. Java is like so complex. You have string, you have buffer, then you have file object, then you have file handlers, then you have file content, file string handlers. It's like that's like Java. Java is like that. Like read file. Yeah, look. So to read a file, you need a file object. You need to create a file object. Then you need to create a reader object. So anyway, yeah. So Java is like kind of one example where the type just bog you down. It's just stupid. Anyway, but back to but okay. Let me so Golang. Today's newer languages, they have what's called type inference. So Golang, you also need to declare types for your variables. So for example, you have these. These are the basic primitive, basic types in Golang. Every variable must be associated with a type, and every value, and every variable as well. So, and let's go back to string. So when you have a var x, you don't see the type here because Golang has a feature called type inference. Now this is true for Haskell and other languages as well, or Camel too. They have a feature of a type inference, so that in many cases you don't have to type, you don't have to enter the type, input the type anymore, because the machine can figure it out. It's logic. It just, so that does, that's tremendously good. This is the right step forward, tremendous good. But still, okay, now back to the original question. Still, we have the question. So do you prefer untyped language, like dynamic language, or typed? I mean, so the question is, okay, so you have type inference, but why do we need type at all? I mean, what way, back to my math-oriented idea, type is just a byproduct of computer engineering. Why do we want to have types? Of course, the industrial programmers, the common answer is that types helps you prevent errors. Well, you can, that's kind of true, but that's not the whole story. But anyway, so back to my own, so I have to deal with this question because I'm interested in languages. Okay, so the short answer, I mean, okay, the final answer is that, oh yeah, okay. So I was going to say, so in the past few years, like the past 3 or 4 years, I started to have a different perspective on typed, or especially strongly typed. Yeah, I have a different perspective now on strongly typed languages like Golang and Haskell and OCaml, because when you are using these languages, the type are very strict. They are strongly typed. The issue about types in programming languages is actually fairly complex. Like if you go to Wikipedia, you can see many articles discuss it in detail. So it's not what a typical programmer would think. But anyway, let's not get into that. But anyway, right now, so there are the issue about strongly typed languages, right? For example, Java, Golang, and Haskell or Camel. So I started to appreciate them because when you program in these strongly typed languages, um, uh, you are like so I start to think of them as a very strict as a logical system. That's a key point, as a logical system. Uh, so are you guys are still here? Like I just monologued for 1 hour, I think. Say something. I think we almost done. But anyway, let me answer back. So I started to view these strongly typed languages as a kind of a logical system, and this is necessary because especially when I started to look into proof systems, math proof systems. Hi, George. So you when you start to study proof systems in math, computerized proof systems, you can see that type is important. In fact, there's type theory. For example, type theory and logic systems, symbolic logic, and you have type theory. It's one of the philosophy of automated philosophy of automated math systems. There are several different philosophies, meaning with different approaches. So type theory, typed system is one of the approach for the foundation of math. And so I started to see they are critical. I mean, they are important and critical because I started to view them as a logic system. So yeah, so I no longer like before, type is just a byproduct of computer engineering. That is still true for Java. For the Java and C and C++, that is still true. Their types is like just a side effect of computer engineering. Okay. Now the viewpoint of looking at strongly typed languages as a logic system applies to Haskell or Camel, F sharp, and you can say Golang too. So that's what I'm saying. So you see, I started to look at them strongly typed programming languages as a logic system, for very strict proofs and stuff. So that is basically my perspective. So, but what about? So let me just like resolve my the paradox. So what about my younger self, where the type is just a byproduct of computer engineering? So isn't the types in Haskell, they are just byproduct of computer engineering? No, because when you actually look at computer languages as a logical system, type is actually necessary. I mean, that's what you want. I mean that's if you look at Haskell or Golang or Camel as a logic system, in the outset, your goal is to want to have the type. You want the type. That's the main dish. So that's why I appreciate them, but not the types in Java or C++ or C. I think those are crap. So that's that is my opinion about typed versus dynamic. I still like dynamic, and I do appreciate type. So if you ask me which would I choose, well, that would depends. I mean, I cannot. I couldn't say. I just pick one answer because because I'm really interested in proof systems. That's what I want to do. But meanwhile, it is true that if you just want to plot, like mathematics, when you want to do scientific programming, usually you don't want types because types actually bog you down. When you do a plot, you don't care about, you are not doing proofs. You just want to see the graph. Or if you are doing statistics, you just want to derivative or, integrate, some equations, some, solution to a matrix, equation. you just want to get the numbers. You are not doing proofs. You are doing computation with math. So for for a scientist, or for many in many cases, or even if you are writing a script to clean your disk or whatever, you don't want types. Usually they bog you down. Uh, even with type inference. But if you are doing proofs, you do want types. For example, in Python, actually, I noticed that Golang is actually more verbose in Python. It's like 1.5 more verbose. Like writing the same program in Python is 100 lines. In Golang will be like 120 or 150 lines. That it turns out to be that case, and other people say that as well. So even Go has a type inference, but still usually typed. So anyway, that I think that's it. So today we talked about type versus untyped languages. Very interesting topic. So Finch ditching them. So Fitch says statically typed plus strong type inference equals to good place to be in. Yeah. Especially if you view it as a logic system. Especially if your goal is to actually do math proofs, or if you want like verifiable programs, something like Fitch says that I'm starting to like dependent types more and more, and type inference doesn't work much there. Dependent types, what does that mean? I'm not much. I'm still learning the subject. I don't know. I haven't coded Haskell actually. So dependent type is like I forgot what it means. Dynamic languages for prototyping, but not for big project. Yeah, that seems reasonable. Yeah. Okay, so I think 1 hour and 7 minutes. I think that's it for today. Yeah. So yeah. So thank you guys for coming. Thank you everyone, and I'll see you next time. Bye.